Good evening, everyone. We will get started in just a minute. All right, good morning. Wow. It's been a long week and it's Tuesday. Good evening, everyone. My name is Jennifer Coffey, and I have the pleasure of serving as ANJAC's Executive Director. So welcome to the first virtual session of ANJAC's 50th Annual Environmental Congress. It's great to see some new names on the participant list and the names of some people who were also with us on Friday at the in-person event. I want to start by saying that this session will be recorded and it will be made available to everyone who registered for the virtual sessions of Environmental Congress. We encourage you to follow us on social media. The platforms we're using these days are mostly Instagram and Facebook, and we have lots and lots of educational sessions like the one we're offering you tonight on our YouTube channel. There are more than 100 different sessions on there. So if you've got a question about it, chances are we've got the answer on YouTube. You can also email us at info@anjac.org. That email address will be coming up again later in my introduction. That's info@anjac.org. And we encourage you to post on Facebook and on Instagram about what you're learning tonight so that other environmental commissioners can hear about these sessions as well. These are the hashtags that we suggest using, and you can check them out on our channels. They'll be repeated there. We want to thank all of our sponsors for helping us make Environmental Congress possible. These are businesses who have presented with us throughout Congress, either in person or will be presenting throughout the week here with our virtual sessions. Many of them are aligned with work that we are doing here at ANJAC, and we appreciate them for making Environmental Congress possible and so that we can bring it to you at a price that is affordable and makes it open for more people to attend. So thank you for all of our business sponsorships, and of course to all of our nonprofit partners who work with us throughout the year on a number of issues. So thank you, everyone. I want to take just a quick minute. I gave a longer presentation of this on Friday, but I just want to recognize as we move into the virtual sessions of our 50th Annual Environmental Congress that we environmental commissioners have been doing this work for 50 years now. And I want us to take a moment and recognize the tremendous leadership that New Jersey has had in the environmental movement and the leadership that they have had in setting this nation on a positive trajectory for our environment. Many years ago, many years ago, we had New York City that on the regular, not just because of Canadian wildfires for one of 2 days, but on the regular looked like this on the left, had that orange-brown haze that people who live there breathed in. And it wasn't just New York. It was New York. It was Philadelphia, where I grew up. It was Chicago. It was LA. It was Texas. We had rivers that were spontaneously setting on fire because they were so incredibly contaminated. We do not have that situation anymore. And it is because, in large part, environmental commissioners said we are not going to take this and we are going to mandate change. And New Jersey stepped up and led the way for air quality controls, for contaminated site cleanups, for wetlands protection, for environmental justice laws, for regulations on flooding and flood hazard that demand the incorporation of climate modeling. We have done very hard things. We have hard things in front of us, but we know we can tackle them. We know we can We can combat the climate crisis because we have done hard things, because we no longer have air quality that looks like the left, and we no longer have rivers that are spontaneously setting on fire. We have made changes, and we will continue to make changes. We want to remind you that ANJAC is here for you as your resource. We are an organization that brings to you small grants, educational resources like we do tonight, technical support, strategy sessions. So please reach out to us on whatever it is that you are struggling with, or goals that you are seeking to make true for your municipality. Reach out to us, and if we don't have the answer, we know where to go get it, and we will help you. We are your partner. We are proud to offer our small grants program. We've given out more than $2 million to communities, to green spaces, create community gardens, rain gardens, adjust flooding, combat flooding. We also want to remind you that many municipalities are on an annual calendar year for their budget. So if yours is, now's the time to prepare your budget. We ask that you consider matches to grants, any educational forums you want to attend, and of course, we appreciate your ANJAC membership so that we can continue to bring you programming like we do tonight. And last but not least, we want to remind you that November 7th is Election Day, and to please do your research about the candidates running for office and make sure you vote. There's lots of opportunities for early voting in New Jersey, and so this is the website where you can find out information about where to go vote if you'd like to do it before the 7th. And with that, I would like to say thank you, and please do stay in touch with us. Follow us on social media, check out our YouTube channel. And I'm thrilled to bring to you Dr. Randy Rothmel on our staff, who is going to provide introductions for this evening's speaker. So thank you, everyone, for being with us tonight. Randy, it's all yours.
Thank you so much, Jen, for kicking us off on our first virtual session of the 2023 ANJAC Congress. We are now going to hear from the core team, the core coastal research team at Kean University on tackling climate change in New Jersey's urbanized coastal communities, focusing on shoreline erosion, water quality, and social environmental inequalities. Tonight we have with us Dr. Chen, Assistant Professor in the Department of Environmental and Sustainable Sciences at Kean University. He holds a PhD in geology. His research interests include coastal geology and coastal engineering management. Dr. Xuting Liu is Assistant Professor in the Department of Environmental and Sustainable Sciences. She holds a PhD from the Marine Science Institute at the University of Texas. Her research focuses on understanding the microbial ecology and marine ecosystem processes. And finally, we'll hear from Dr. Galia Chakri, a postdoctoral fellow in the Environmental and Sustainable Studies. She's a social scientist with a focus on community and neighborhood development and redevelopment issues pertaining to equitable pertaining to climate adaptation and green infrastructure planning. So, Dr. Chen, if you can start, Jen start sharing, and Dr. Chen, you can start sharing your screen, and we will begin our presentation for tonight. I want to tell everyone, we are going to hold questions to the very end, so please use the Q&A feature at the bottom of your screen to ask questions, and then we will ask our panelists at the end of our session tonight. Thank you very much.
Thank you. Can everybody see my screen or hear me?
Yes.
Yes, we can. Thank you.
Okay, good. I just try to move this something because it's something in the way it's blocking my screen. Okay. Hello, everyone. And thanks for the introduction. Again, my name is Jun Chen, and I'm a coastal geologist. What I study is the beach erosion. So here I'm presenting several, mostly focused on one case study I recently conducted along our coast. And my study area covers the coast facing the Atlantic Ocean, as well as facing the bay, for example, Raritan Bay, Sandy Hook Bay, as well as some estuaries. And so the topic I have today is storm-induced beach changes along New Jersey coast. All right. Okay. Yeah. Our Atlantic Ocean is pretty active this year, weird or not. Actually, that's a part of the deal of global warming, because our ocean temperature is getting warm and warm. The chance we get hit by hurricane is larger than before. And the picture on the left-hand side is the passage of Hurricane Lee, and which is a bit far away from us, right? But it still generates waves and elevated water level. It actually made landfall in the Gulf of Maine here. And it happened in the middle of September. And immediately afterwards, I believe like just one week later, maybe 10 days later, and our coast was heavily impacted by this hurricane called Hurricane Ophelia. And I think most of us maybe still fresh in your mind. And our state, New Jersey, New York, and Connecticut suffered a lot by the flooding from the hurricane of Ophelia. That's about like 3 weeks ago, roughly 3 weeks ago. But as a coastal geologist, my focus is mostly on how these storms induced waves, induce the water level, cause sediment move, and the sediment move and it will cause the erosion. So that's what I've studied. So let's look at some data here, which one data is here, where my cursor is pointing is a wave gauge operated by NOAA. It's about like 20 miles offshore. And as you can see, that's 1 month, almost like 1 month of a wave record. And that's the wave height. The unit is in feet, starting from September 14 all the way to today. And you can see we have several peaks here, right? And the first peak is actually associated with the passage of Hurricane Lee, because it's a distal passage of hurricane. The wave is not too big. The second one actually is pretty big. It's very energetic condition. The peak wave height can reach to 13 feet, and actually lasted very long, because Hurricane Ophelia, after that, there's some disturbance in the atmosphere causing a northeaster. That's kind of heavy wind, and the waves last very long. And after that, our ocean died down. And so you will see the red line I'm marking here is actually the time I conduct beach survey. So you will see I made like 5 measurements, 5 times, went there 5 days and collect the beach profile data, and I can compare. That way I can tell how they change, as you will see later on. This is the one thing, wave. We have very energetic wave condition during this hurricane season. Number one. Number two, on the figure down here, that's the water level changes. And that's the tide, basically. It's up and down, very regularly every 6 hours, right? And every 14 days, we have a spring tide, a neap tide, that's cycle. And the blue line shows the measured, that's the predict water level. Basically, we don't consider the storm. And the orange line is actually exactly what we measured at Sandy Hook. So you will see that our water level is elevated, caused by what? Is by the storm, because we have so many storms coming in. Our water level approximately elevated by like 2 to 3 feet. So think about it. We have elevated water level. On the top of that, we have big waves. That's the condition we are facing now. And I have a study area that's located in the Ocean County and Alderley Beach, and maybe some of you guys are familiar with. I have a photo here, and the reason I picked this as my study area is this is what we call erosional hotspot. Just this beach here, the stretch of beach here, somehow that's what we study. Why it is getting eroded very badly. Number one. Number two reason is actually every time I went there to beach survey, I went around, oftentimes I run into local residents. They keep telling me, remember, almost 11 years ago, this town, Audley Beach, almost entirely wiped out. And this is actually one of the location where the ocean and the bay connected, completely flooded. So this is a very vulnerable piece of land that we need to study how they change. So if you look closely here, all this actually that's the dune. The dune grass is very, very regular. So we know that our mother nature don't do this. Actually, that's the man-made grass, and we plant the grass there, and the grass actually promotes the dune growth. That's one of the lessons we learned from Hurricane Sandy. Wherever we have big, taller dune, the infrastructure landward can get protected very well. So is the beach. We have wider beach, and we have better shore protection. That's the lesson we learned from Hurricane Sandy. And so based on the reason, this is the erosional hotspot. I picked this study area, try to document how the beach changes in this particular area over the last 1 month, basically, most recently. And this is several pictures I show here. And the picture was taken September 28th. And at that time, we are still in the mode of the Hurricane Ophelia, just a little bit dying down, but not quite. As you can tell, offshore, the wave is very big, right? It's windy and rain, but we still went there, but I didn't regret. I think we have very good photos. For example, here, this is what? The black stuff actually is called a magnetite. It's iron oxide. It is a iron oxide. It's pretty heavy mineral. How do they form? It's actually formed by the storm. When the storm comes in, energetic condition kick in, and all the lighter siliciclastic sand get washed away. Only this heavy mineral get settled down and accumulated somehow. So this is an indicator of the storm event. And so this picture show here, and my student was holding the what we call RTK GPS. Is very accurate GPS system, try to measure the XYZ points on the beach. And where he's pointing is a scarp. It's a very steep slope and formed freshly by the storm. And this one is even this is the dune scarp, and the dune scarp pushed in, and even the broadwater will get exposed, and the people, I think later on, close the broadwater because it's kind of dangerous. People get in, they fail. So that's the situation we run into most recently. And so we are using the RTK GPS, try to document how they change. So very quickly, what do I mean by RTK GPS? Is everybody have a smartphone, and your phone have GPS, but the GPS we have on my phone is not accurate to measure this kind of changes. So the RTK GPS we have is it's the same thing. Is received signal from the satellite and determine where it is, X, Y, Z location, right? So not only this, we have a base station. The base station is a GPS that occupy a known position. The accurate position is known. So what we're doing is we constantly compare what we measured from the satellite to the known position. Then we get an error, right? That's become actually a correction. This correction can be transformed through the Wi-Fi or cell phone carrier to the rover that's actually we are holding on the beach. So based on the satellite signal as well as correction, our RTK GPS can get very accurate. The accuracy can within centimeters, but our phone, the GPS probably tens of meters. So this is some of the equipment we have. And okay, and so this is our study area, right? Audley Beach is somewhere here, and we occupy 20 survey lines. So we reoccupy this line every week for almost 5 weeks, for 5 weeks. So that way we systematically document how they change. So the each line is spaced out like 100 meters, and it is starting from the dune all the way to the water edge, So we actually occupy 3 cities. The Audley Beach is in the middle, right? South of it is Seaside Heights. We also occupy several lines over there, and the north of it called Lava Lake Beach. We also have lines. So anyhow, totally we have 20 lines, and densely covered. Also have a pretty intense service. So let's just look at a few lines as an example. I don't have time. We don't have time to systematically go through all this. I just pick you 3 of the lines and give you a taste of how they look like. So this is a line located at 7, which is somewhere here in the middle. It's in the Outlet Beach, and the red line is a beach profile starting from the dune. Is the topography changes. Starting from the dune, which is high up, right? Then you go down, that's the beach, then go all the way down to the water. That's 0 elevation. That's the red line is measured before the Hurricane Lee. There's a very early survey when the school just started, September 14. And 1 week later, that's measured by the 10 line at the exactly same location, same profile. That's measured after passage of Hurricane Lee. But Hurricane Lee, we know, is very far distance away. Hurricane is not too much, but still we see some erosion, right? You see the shoreline retreated. And so 1 week later, that's the real measurement. That's the 1 week later, and actually that's the picture you see earlier. We went there in that rainy day. That's September 28th. And that's almost after the passage of Hurricane Ophelia, and this is a big hurricane, and a lot of beach get eroded, and the shoreline, I mean the water level, the mean high water level about 0.7 meter. That's elevation. This line retreat about 50 feet. It's very considerable, huh? Very, and it's a very large number. And the dry beach, if we with that, we can actually calculate the volume. That's the question I often run into on the beach. So people ask me, "What are you doing? What are you guys doing?" I'm saying I'm measuring for beach erosion. Then the next question will be, "How much do we lost?" So I may say, "I don't know because I need to calculate it." That's what we do. So we have the lines, then we play with the geometry and get the area, and basically this area is an area we lost, and the lost volume is about 50 yards per yard. So that says, so each yard of shoreline we lost like a 50 cubic yards of sand. That's considerable, right? So you may say if we times this for like 1,000 yards, is that right? You will see later on, huh? So that's the one part we have. That's the peak of the storm. And later on, 1 week later, we went there again. Actually, that's the blue line. That's what the blue line shows. The blue line shows 1 week later, as the wave dying down, the beach actually naturally recovered. And I think 1/3 of the dry beach which was lost and actually get recovered. That's what is reflected on the blue line. And we have one more line. the last one, we just went there most recently. That's in the October 12th. That's a black line. That's a black line. So we still have gain, but it should retreat a little bit based on the previous one we had. So this is the first line, and you may ask, why do we need to measure so many lines? So that's the reason I'm showing you here. The second example shows very different pattern, huh? That's at the profile 12, which is a little bit north of what I just showed you earlier. So the red line is pre-storm, before the storm, Hurricane Lee, and the 10 line shows after hurricane, after the passage of Hurricane Ophelia. Yeah, I only have 3 lines for this one. I just showed 3 lines. So you will see the beach erosion is not so as aggressive as the one I showed you earlier, because only 20 cubic yards per yard of sand was eroded, number one. Another difference is not only we have some shoreline retreat, right? The shoreline retreat from here You see, that's the shoreline we have retreat back to this place. Shoreline retreat about 11 feet, shoreline retreat 15 feet. Not only that, we have dune erosion. You see here on the top is the dune. Actually, I captured the dune here. So this dune retreated back about 11 feet. So that's what we didn't have in the previous line, right? So why the dune erosion happened here? That's something question we need to answer, huh? So later on, so although our beach recovered, right, as the wave dying down, the beach recovered, but the dune scarp still remain the same. This just indicates the dune is very fragile. Once it get eroded, it's very slowly to get recovered. But the beach may be a different story, huh? Beach recovered very quickly. One more line. I know you get a little bored. One more line. This is the last line, last profile, which is on the almost at the Loveland Beach. It's a northern end of the study area. And this, I show this just indicate that the longshore variation is very considerable. What I mean by longshore variation, some profile is eroded very badly. Some profile is kind of stable. This is maybe one example shows that our shoreline is stable over there, and actually, and mostly stable, I would like to say. Most also interestingly, during the recovery phase, the dry beach actually gained something. You see the elevation get increased, that just shows they gain something. So why is this, right? This is what I'm studying. So before I study this, I have to systematically document this, what happened. Okay, so one practical application of the study is, so we can, with this densely covered line, we can calculate very accurately how much volume of sand get lost. And I used to work in Florida. You know that Florida has a spectacular beaches. And when I was working with Florida over that time, and every time hurricanes hit, and the county or the town will claim some FEMA money based on what? Based on how much volume of sand they get lost. So this is a data very valuable, and practically, and for each local town can calculate their loss, right? This is from the practical end to say the importance of this work. And more importantly, I'm not saying more importantly, and on the other hand, scientifically speaking, I can use the data to link, like each time when the beach loss, link with offshore wave energy. Under the condition of the climate change, we may have more rough ocean, right? So how can we use this data to predict what we have in the future? And also, our department have experts on remote sensing, and I'm talking with him and try to develop some algorithm, use the data I just showed as a ground control data to verify remote sensing images, because remote sensing image can do very large area, and also has a more time frequency, and also go back to maybe decades of this kind of data. With that, we can predict robust forecast for our shoreline, maybe do a mapping of coastal vulnerability. So that's actually the ongoing research for this related to what I just talked about. So in addition to the beach study I conducted on the Audley Beach and along the Atlantic Ocean, I collaborated with Montclair State University and study at the Long Branch Beach, and which is actually a funded project by New Jersey Sea Grant. And Montclair State University, their part is do the drone, all the fancy drone, and they can measure this the beach changes, mostly in the dry part, the above the sea level. So what I'm contributing here is, so our lab equipped with echo sounder, right? I already introduced the equipment of RTK GPS. We also have an echo sounder, and this can be mounted on a boat, something like this. And if we drive around on the boat, can help to mapping the seafloor. This is a piece we're missing for the beach profile survey. The beach profile I'm holding with the RTK GPS. I can only go to the water edge because this thing cannot go in the water. With a boat, with the echo sounder, and we can extend our survey, because that's actually where the sand come in and go. It's a very important portion that we cannot miss. And I'm exaggerating here. We don't have this fancy boat now. I just put the picture here as an example to illustrate. And we actually right now have a canoe. I'm going to launch the canoe in the ocean tomorrow. Hopefully, finger crossed, it will work. So this is some actively ongoing research. And beyond that, around the bay, very quickly, and this is another project funded New Jersey Sea Grant. It's mostly for outreach. One place is in Jones Cove, located in Elizabeth. Another location, Elizabeth, is here, and another location is Keyport Coast. And for Jones Cove, we know that Jones Cove is very close to this. Jones Cove is reflecting the photo here, in the up panel here, and it is very close to the Newark Airport, International Airport. And associated with the airport, we have very large port, the seaport. And the seaport will have a tremendous amount of cargo ships, right, coming in and out every day. What this ship do is, this is the photo we took during the summertime at the Jones Cove. And this big ship can generate big waves, right? The big waves generated by ships actually eating up the seagrass at this wetland. Originally, the wetland was to protect the shore, maybe because of the busy channel and the wave coming, and also when the storm coming, the water elevated, right? Elevated water level. On top of that, the wave generated by the wind and the boat and the big ships, and it will eat up all these wetlands. And I systematically document how they change with RTK GPS2. Also, this is me try to deploy the wave gauge. This is this RBR wave gauge, can deploy in the shallow water to measure the wave. That's what we conducted at the Jones Cove. And so, by the way, this project also collaborated with my department chair, Dr. Diana Shipitz, and she's an expert in plants and ecology. And so we work together very well, because I study how the wave impacts the coastline. Actually, in this case, impact on the plants. And so Dr. Shipitz is helping to assess to survey the wetland. So survey the wetland, we combine together, because this is actually a living shoreline project. So living shoreline means how can we use this living stuff to protect our shore. So this is two projects. This is several projects I have, and to wrap up. And I would like to say, as a beach person, I would like to say a beach is a very dynamic environment, and the measurement with a high spatial and temporal resolution is very important to get the changes. So ground measured survey is very important. That's what I do. And we can provide, as a lab, our lab can provide systematic beach surveys and conducting wave and tide bathymetry and measurement to investigate the mechanism, how they change. So and by collaborating with our department at King, and our team can also assess the effectiveness of living shoreline and other shore protection measures. And that's all I have. I do. Thanks for all your attention, and also thanks for a few of my students, and Michael and the Dollars helped me with the field operation. And also this study was funded by our university, as well as I think two New Jersey Sea grants. Thank you. Yeah.
Thank you so much, Dr. Chen. We can now are going to be hearing from Dr. Liu. So if you can stop sharing your screen, and then Dr. Liu can take over. Thank you so much. That was very interesting.
Thank you.
Hi, everyone. Is the screen okay?
Yeah, if your slides are good and we can hear you fine.
Sure. Thank you. Good evening, everyone. My name is Xu Ting, and thanks for the invitation from the organizer. I'm glad to be here today to present some of my research on investigation of water quality and algae bacteria interaction in New Jersey coastal waters. So you may wonder, what is actually water quality? It describes all the conditions of the water, including both your chemical, physical, and biological characteristics of the water. You can measure the water quality from all different sorts of parameters, such as some physical parameters like your dissolved oxygen in the water, your salinity in the coastal water, or turbidity of the water, or some chemical characteristics like the quantity of some contaminants in your water, such as pesticides, herbicides, heavy metals, or some biological parameters like your bacterial levels, your concentration of some algae in the water. And my research focused on the algae-bacteria interaction. And why do I choose this as my topic? It's because of the important role of algae and bacteria playing in the water. So the algae, basically, they are those photosynthetic organisms in the water. They contribute a lot to the primary production and serve as the base of the food web in coastal water. And for the bacteria, they're the natural decomposer. They decompose some of the waste, some of the remains of the other organisms, and also a lot of organic matter produced by the algae. So they can regenerate those nutrients for some other organisms to use. So there's a tight relationship between the two different kinds of organisms in the water, and they are also important to assess our water quality. So if you think about all these different bacterial and algae component in the water in this picture as an underwater household model here, you can think of the algae as basically like a cooker inside of the kitchen under the water. They are preparing the food, the organic food for the other organisms through the photosynthesis. And after they produce those organic matter as a food, the bacteria will consume this organic matter food and then regenerate the nutrients for the others to use. And some other unused organic matter will be left over and accumulate in the water. So there's actually algal blooms happening in the New Jersey in the past and also happening right now in different over the years as well. So what do you mean by the algal blooms? It's just excessive growth and overgrowth of a lot of the algae in the water. And it has been documented in the past decades in the New Jersey coastal water by different studies. And if you can monitor the algal bloom by looking at the satellite, as you see in the right side picture here, where you see all this green color showing you the overgrowth of the algae. And sometimes if there are certain algae, certain algae dominates the water, they can actually produce some toxins which are harmful to a lot of the organisms and also humans in the water. And those algae blooms are called as harmful algal blooms, HAPs. And those produce toxins. They can be accumulated in some seafood that our human actually will consume. So depending on different kind of the algae species dominating in the water, sometimes you will see the color of the water dominating with the algal blooms showing as this green color, dominated by some cyanobacteria, as you see in the left picture. Sometimes you will see some of this red color, which people call it red tide, which are some kind of the algal blooms that has been documented in the Hudson-Raritan estuary in New Jersey. And some other times you will see some algae produce this brown tide, which are also one kind of harmful algal bloom has been occurred in the Baltic Bay area in New Jersey in the past as well. So you can imagine some of the impacts introduced by the algal blooms. First, you can see that because of the algal bloom, you will produce this murky and turbid water as shown in this picture here. And also because of the overgrowth of the algae, it will produce a lot of the organic food for the bacteria and fuel the bacterial growth. And then those growth of the bacteria, they will consume a lot of the oxygen in the water and producing something we call like dead zone, which is a low oxygen water. And also, some of the algae, if they produce those hazardous toxins, they're detrimental to not only the organisms living in the water, but also to humans once we consume some of the seafood from the water. So then we know this occurrence of the algal blooms. Then next thing we want to understand what are actually the drivers for the algal blooms. So the common consensus are a couple of the things may be the driver for the algal blooms, such as the nutrient, including some of the nitrogen nutrients like nitrate, ammonium, and phosphorus nutrients like phosphate. And also sometimes related to the hydrodynamics of the water, some water circulation, or related to some kind of the algae lifestyle and their species found in the water as well. So related to the first driver of the nutrient leading to the algal bloom, you may have heard of the word eutrophication quite a lot, which means that excessive nutrients that run into the water, they can come in from some agriculture fertilizers that have been deployed on the land, and then through the runoff leads to the water that are going to trigger the algal blooms in the coastal water. And also, if you relate the algal blooms with the climate change, people tend to think that algal blooms may become more intensified in the future under the climate change, because with the global warming, you have higher temperature in the water, so that favors the growth of the algae over time as well. So studying the algal blooms will also help us to understand how that will happen, what will happen, and how the water quality will change under the climate change. So my research question is try to assess how do the New Jersey coastal water quality and algae-bacterial interaction vary over both temporal and spatial scales. So our King University has been identified as the first urban research university. So my research is also related to the urban development. You can imagine with the urban development, we have excessive overload of the nutrient into the water, which triggers the growth of the algae, and the algae will release something called the dissolved organic matter, DOM, which are the food which going to fuel the growth of the bacteria. Some of the DOM also contain the harmful toxin produced by some harmful algal blooms as well. And those DOM produced by the algae will be used by the bacteria, and bacteria will regenerate the nutrients that can favor the growth of the algae again. So it's like all these different components linking in this loop and cycle here. And my research are going to focus on all these different components in this loop, including nutrient, algae, bacteria, and DOM. So in my research, I have combined both field study and in lab incubation. We were conducting some time series study on the New Jersey coastal water. As we mentioned before, we have there's occurrence of the algal bloom events in the New Jersey, and we also find harmful algal bloom species in the New Jersey coastal water in the past already. So we want to understand how the water quality are changed by this algal bloom event, and how that's related to some nutrient in the water, and also what those nutrients and water quality may vary over the spatial scale. So we're using the Keyport Harbor as our model study site. As you can see, we have 4 different sites labeled on the map here, and the site 1 and site 4 are close to the left side and the right side of the Keyport border. We're captured by the 2 different creeks. And the site 2 is close to a recreational park. Site 3 is close to a paving and seal coating company. So we have conducted some field sampling of the water and analysis of the different water parameters. We have done some seasonal field sampling of both inorganic nutrients, dissolved organic carbon, chlorophyll, which is the indicator for the algae biomass, and the bacterial abundance across multiple sites we see before in the map. And I'm going to present some of the field data we collected during the summer. And this work has been conducted by 3 of my students, Chelsea, Ben, and Derek, in the summer with me. And we went on the Keyport side for the field sampling, analyzed the dissolved organic carbon using the TOC analyzer, which is the instrument analyzing the DOC. And then we look at the chlorophyll and the nutrient using another instrument called spectrophotometer, and we'll count the bacterial abundance under the microscope. So first, let's take a look at some physical parameters associated with the water. So in these photos on the left, you can see it's two photos taken on the same exactly site in the month of May versus the month of July. So we can see that first thing you can tell is like the water level are pretty different depending on which season you are in. And also the water color will change over the time as well, which may be related to some algae that we are going to cover in 1 minute. And also looking at the right figure, you will see that, of course, changing from the spring to summer, we see an increase of our water temperature, as shown in the blue line. And also we see a decrease of the dissolved oxygen in the water, which is mainly due to the lowered solubility of the gas in the summertime, and also possibly related to some growth of the algae, which we'll just talk in the next slide. So we monitor the chlorophyll A concentration change, which is the indicator for the algae growth in the water here. And in this plot here, you will see like the 4 different sites showing in here on the x-axis, and the different colored bars showing here basically the temporal change of the chlorophyll A of the algae biomass growing. So we can see that the overall pattern over the temporal scale on all 4 different sites, you will see like an overall increase of the algae biomass in the summer, except for the month for the June. And this overall increase of the pattern of the algae biomass actually coincides and corresponding matching pretty well with the data we get from the NJDEP with their monitoring site in the Keyport Harbor as well, which is a little bit further away offshore from what we are collecting the water from. And also, you guys can see there's a dip in June of the algae chlorophyll A in this plot here. And this is actually the month that, if you remember, that happens with the wildfire from Canada and the smogs in New Jersey. So some possible reasons, for example, like the dust will block the sunlight for the photosynthetic algae, and also possibly some deposition of some harmful toxins that may inhibit the growth of the algae, which may lead to the pattern we see here. And also, not only the temporal scale, we see like some spatial variabilities. For example, the site 2 overall, especially in the summer, seems to see higher algae growth compared to the other side. So next thing we want to see, what is actually the driving factor for the algae growth in terms of the nutrients. The plot here showing you the ratio between the nitrogen and the phosphorus, and we can see this pattern that basically this ratio between nitrogen and phosphorus has a dramatic decrease in the summer months compared to the spring months, which indicating that those algae are taking up a lot of this nitrogen for them to grow in the summer, and then nitrogen may be the limiting and the driving factor in the Keyport water for the algae growth in the summer. And next thing we want to look at what is actually the nitrogen species dominating and driving this algae growth. So we look at the correlation between the different kind of the nitrogen versus the chlorophyll A concentration. So we can see the nitrate and the nitrite, it doesn't explain the chlorophyll A concentration too well. We only have R squared, which explains the correlation between the 2 sets of the data with a very small number here. While the ammonium is another nitrogen that actually correlates better with the chlorophyll A algae concentration, and which explains that probably the ammonium is one driving factor for the algae growth in the summer. However, there's possibly, it's not the only driving factor. There's possibly some other factors driving the algae growth in the summer as well, and possibly different kind of algae, they may use different kind of the nitrogen species at various times as well. So that's why we sometimes don't see this correlation in all different a good 100% correlation there as well. So my intern student, Spencer Thompson, has been taking some of the algae images under the microscope. So just you guys can see there's all different kind of the algae with different shapes living in the water. That's also possible that they may take different strategies to use the nitrogen and using the different resources in the water for them to grow in the summer as well. So not only the field studies, I'm also conducting some of incubation studies in the lab by growing the algae in the lab and also harvesting some of their produced dissolved organic matter, feed this dissolved organic matter to the bacterial communities from the key pot water, and then monitor the decrease of dissolved organic carbon through the incubation time and the increase of the bacterial abundance over the time as well. So here is the data we conducted using this incubation studies, and you can see that the blue line shows the control treatment where we don't have any algae DOM added into the water. However, the orange line showing the treatment that we have the algae DOM feed to the bacteria from the water. So you guys can see that with the time showing on the axis and the DOC concentration showing on the y-axis, we have a very high bacterial activity in the summer, basically drawing down this algae produced DOM within like 2 weeks in the summer, we're reaching like similar values as the control treatment after 2 weeks. And our next step is trying to compare this bacterial activity from the summer versus some other studies we're going to conduct in the winter. And our hypothesis is we'll probably have less active bacterial activity in terms of using the DOM from those algae in the winter time compared to the summer. So in conclusion, we have seen the algal blooms occurred in the summer in New Jersey coastal waters, and nitrogen may be one of the driving force for the algal growth in the New Jersey coastal waters. And our next step is to collect more temporal and spatial data to assess and set up some baseline for some future management planning, which will help us to understand how to cope with the natural or anthropogenic disturbance in the future as well, and aiming to increase our coastal resilience at the same time. Also, understanding those effects of the algal blooms on water quality is essential for us to assess the coastal water ecosystem health, especially under the big picture of the climate change. And at the end, I want to thank the funding source from King University Student Partnering with the faculty program and the Keyport Council for supporting us with access to study at the Keyport, the NJDP providing the long monitoring data, and our college providing a lot of the resources. Thank you.
Thank you so much, Dr. Liu. Your research really takes me back to the time when I used to be in the lab, because I used to work for an environmental biotechnology company, and I used all this equipment that you were showing us. So it really takes me back to my previous career. Thank you so much. It was so interesting. Our last speaker will be Dr. Shockley. So we'll hear from our last speaker, and then we'll take questions. Present our questions to our panelists.
Hi, everyone. I think you can see my screen, right?
Yes, we can. Thank you.
Yes, good. I'm just pulling up mine here. Okay. Okay, good evening, everyone. Thank you so much for being here tonight. So my presentation is taking a bit of a different turn from the previous two presentations from my colleagues. I'm a little bit sort of the different person, the social scientist person in the environmental science department. So mine takes more of the turn in the direction of the social impacts of environmental planning decisions, and draws on results from 2 empirical studies from my PhD research, which examined how greening and urban redevelopment can combine to actually increase climate insecurities for socially vulnerable residents, in particular through gentrification processes. So one of my studies has been published in Urban Climate, and the second one recently in Housing Policy Debate as part of a special issue on housing and climate change. I'm happy to share those papers with anyone if you have any questions that get a little deeper into the issues. So for anyone that's upset about missing the Phillies game, which I heard is tonight, this presentation is actually in part about Philadelphia, so maybe that provides some consolation. I'm presenting this work, which has really provided a foundation for research that I would like to develop as I'm sort of new and old in New Jersey, that, for research that I'm trying to develop to benefit New Jersey coastal cities and towns. So I do focus more on my research in Philadelphia, but I hope that we can talk about ways in which this can be beneficial and useful for New Jersey cities. So to begin with, there were a few key motivations that were developing these studies. One, that green infrastructure such as rain gardens and green roofs, wetlands, and living shorelines can have myriad social, health, and safety benefits. And increasingly, green infrastructure is also being planned and implemented to make cities and towns more resilient or adapted to the increasing intensity and frequency of climate impacts. So, however, green infrastructure is also often highlighted for its potential to enhance economic growth by making cities more attractive, more beautiful, also by participating in the green branding of cities and towns. And so in this picture, we can see all the many parks and greenways that have been planned, some of which have been implemented already in the lower income neighborhood of East Boston, which is right up against Logan Airport. And overall, historically, has not been a very green neighborhood at all. So in recent years, more attention is being given to ensuring that these green infrastructure projects are more equitably distributed, reaching in particular overburdened neighborhoods, which tend to be less green and more exposed to polluting facilities and infrastructure, such as highways and airports. Overburdened neighborhoods are those where at least 35% of households are low income, at least 40% of the residents identify as belonging to a minoritized group, or at least 40% of those households have limited English proficiency. And so recently, the federal government's Justice 40 initiative, which you may have heard of, aims to deliver 40% of the overall benefits from federal investments in climate and clean energy to overburdened communities, such as those that we can see in dark blue in this map of New Jersey. So it looks like, we're moving in a good direction for ensuring that everyone gets better environmental protection, better climate protection. Well, our research sort of shows that protecting overburdened neighborhoods, however, through resilient infrastructure may in fact perpetuate climate insecurities and inequities through a process called climate gentrification. That's not to say that those overburdened neighborhoods should not be protected, but it just means that we need to unpack the mechanisms and drivers that are underlying this vicious cycle so we can figure out what to do about it. And so our studies have kind of aimed to develop a methodology for predicting which neighborhoods may be most sensitive to gentrification as climate resilient infrastructure goes in, and to what extent adaptive capacity in these neighborhoods can maybe help to mitigate the displacement of socially vulnerable residents. So it's really about taking a longer view of the impact and benefits of climate adaptation. So our research question is, to what extent do green resilient infrastructure protect vulnerable groups, or do they actually lead to new inequities and insecurities? Well, my studies have attempted to respond to this overarching research question, and I'd like to get some definitions out there. So what is climate gentrification? This is often theorized to be a process in which climate change risks, impacts, and/or adaptations can interact with socioeconomic and physical transformations to urban neighborhoods and spur new inequities. So a few years back, a paper came out in a journal called Environmental Research Letter, and it was theorizing climate gentrification sort of for the first time, even though folks had been doing research on it before, but this one sort of built out a framework for theorizing climate gentrification by describing three potential scenarios. You might have heard of some of these. So the first one kind of hypothesizes that high-income groups are going to move away from high-risk areas where, for example, there can be devastating loss due to sea level rise, and that they, might move to lower risk, but also lower to middle income areas. So Miami is kind of the classic example that the authors tested. They were finding that elevated, more inland areas of Miami that were less exposed to sea level rise were where the real estate prices were increasing faster than the lower coastal areas. So, the historically lower income neighborhoods were seeing their prices go up basically a lot faster than those historically sort of South Beach type of areas in Miami. And then a second pathway suggests that in some places, only wealthy people can afford to live in high-risk areas. And Venice is kind of given as an example. And in such places, residents may be able to afford to rebuild privately in the aftermath of climate impacts, or to use their own private means to better adapt to climate risks, right? So that would be a second pathway of climate gentrification. And then a third one proposes that public investment, has to do with public investment in climate resilience. And this one suggests that new climate resilient infrastructure may indirectly increase local property values. And this is the one that my research focuses on, although we go beyond sort of just looking at property value increases and looking more at what sort of the social impacts of that are in terms of displacement and then re-exposure to new climate risks. So for my studies, I selected Philadelphia as a case study because it's been emblematic of urban green adaptation practice. Philadelphia is also a city that we can say is recovering from over 6 decades, I guess, of disinvestment affecting in particular communities of color. And since the mid-2000s, this vision pictured here of a vibrant, green, and resilient Philadelphia has really guided the city's strategic planning process as a means for advancing urban and economic redevelopment through greening, through neighborhood beautification, and increasingly through climate resiliency. Well, as a part of Philadelphia's Green City Clean Waters Plan, the city created a variety of tools to capture stormwater overflows, to mitigate environmental impacts, to reduce climate risks from flooding and heat. And these tools have included things like what you see pictured here, like rain gardens, tree trenches, green roofs, bioswales, and wetlands. And so I used a selection of these in our study, which I took from open source data, and I prepared them for using in GIS mapping software. And I'd just like to point out that also these types of tools that I showed in the previous slide were also to be implemented as part of other programs and objectives that had that had other, more social or health-related or economic objectives. So for example, addressing a lack of green spaces in schoolyards, improving residential and commercial facades through planters and rain gardens, revitalizing parks, and contributing to cleaning up the 40,000 vacant lots, which are seen, which are sort of remnants of this period of disinvestment in Philadelphia, seen as exacerbating crime and reducing property values. Okay, so now for some of the results here. So this map represents the first part of our results. The turquoise dots are the green resilience infrastructure, which I can't remember now if I've told you, but I call it sometimes GRI for short because it's a mouthful. So the turquoise dots are GRI that were implemented from 2000 to 2016. And we found that they're most concentrated in Philadelphia's downtown and adjacent neighborhoods. The other colors have to do with the combined social and ecological vulnerability of census tracts. We studied social and ecological vulnerability over a few different periods, and I'm showing the last period here. The dark blue tracts are the most vulnerable, so both socially and ecologically. They're warmer and wetter than other areas. And the yellow tracts are the least socially and ecologically vulnerable. The orange tracts are those that received the most GRI, those that are inside the circle. And that is where you have low social vulnerability, but high ecological vulnerability. So overall, we're observing from this first part of the study that the more ecologically vulnerable, but less socially vulnerable areas are those that have tended to receive more GRI. And then in this second slide, we can see our results from examining gentrification over time in relation to the implementation of green resilient infrastructure from 2000 to 2016. And we found that, in fact, that the same encircled area is where most of the gentrification in Philadelphia also took place. So we also found that the higher the gentrification score of a tract, the greater amount of green infrastructure it had been receiving. And then lastly, we examined whether socially vulnerable residents were disproportionately affected by the siting of this GRI. And we found that the downtown gentrifying neighborhoods, those that are now shown in the dashed circle, that received the most GRI also experienced losses of socially vulnerable residents by up to 64 percentage points. So we further found that percentages of residents that had, that percentages of these socially vulnerable residents had significantly risen in some of the warmest, most impervious and least climate protected areas of Philadelphia, as shown by the solid circles. So when we compared these maps basically with the first maps that I showed you, we could see that the most ecologically vulnerable areas now had received the most socially vulnerable residents. And that wealthier residents had essentially increased in the newly cooler, more permeable areas of downtown. So these findings were pointing to this process characterized by the displacement of socially vulnerable residents through gentrification to more at-risk areas, and the shifting instead of the eliminating of climate risks and insecurities. And so I just threw a few of these pictures up there that I kind of grabbed quickly off of Google Maps, just to give a sense of the conditions of these gentrifying neighborhoods in Philadelphia versus conditions of the neighborhoods to which, which residents were now being displaced to. So in the second study, we wanted to understand how it might be possible to predict and prevent such a scenario in the future. So in that case, we looked at future planned GRI and multiple factors that prior research has shown to generate vulnerability to gentrification. I'm going to stop this fan here because I think it might be very loud. We built a custom vulnerability index by adapting a common assessment framework, which is 3 dimensions: exposure, sensitivity, and adaptive capacity. And in our customized study, the exposure risk or stressor was actually defined as the green resilient infrastructure. And the sensitivity factors were defined as those that might augment a neighborhood's likelihood of gentrifying, while the adaptive capacity factors were defined as those that could help mitigate climate gentrification or moderate the likelihood of the displacement of socially vulnerable residents. So we really wanted to understand, again, predict where areas might be most at risk. And so overall, in this second study, we, okay, here we go. So the green highlighted areas give examples of some of the many variables we used to create a map of vulnerability to future climate gentrification index for Philadelphia, and how it could be a model for bringing together those issues, right? So we looked, for example, for sensitivity, we selected data like blight certification, building permits for new construction, economic growth programs like empowerment zones or opportunity zones. And then for adaptive capacity, we wanted to expand beyond affordable housing as what is typically thought of as the key infrastructure for resisting displacement, and look at other factors such as affordable healthcare, accessibility to affordable healthcare, accessibility to affordable childcare centers, higher capacity community organizations, anti-displacement programs, among others. And so I'm not going to go into the methodology, which I'm happy to share my paper with you or answer questions about that if there's interest, but I want to share some of the results. So our results yielded 4 main typologies of neighborhood vulnerability to gentrification, which are represented by different colors on the map. And essentially we found that the future plan GRI, shown by light green dots, is concentrated, continues to be concentrated in the tracts that are sensitive to gentrification, that have already, many of which had already started to gentrify. And those are the ones that are dark purple and fuchsia. And then very few tracts actually showed adaptive capacity to gentrification, those that are in orange. And we also found a high concentration of GRI planned for the yellow tracts, those that are sort of at a tipping point. So you could say that they might be destabilized by the addition of new GRI without actually strengthening the adaptive capacity of those residents. So overall, we can observe that the future GRI were planned for the now wealthier and gentrified central areas of Philadelphia in the dark circle, as well as adjacent tracts that were undergoing economic reinvestment through activities that research has shown tends to strongly increase sensitivity to gentrification. And then lastly, I want to share with you our findings from the semi-structured interviews that I conducted with community representatives, city activists, environmental nonprofits, planners, and policymakers in order to kind of ground truth and expand on these quantitative findings. And the goal there was to understand how GRI were actually being procured and implemented in vulnerable neighborhoods, how the communities perceived greening more broadly, which factors were perceived as gentrification pressures, and what they considered to be the strongest anti-displacement tools. So as a part of the interviews, helped to shed light on how city and environmental groups in particular were striving to be more, in one person's words, well-meaning in their work, and in some cases exploring how to center equity. As a staff member of a national conservation organization put it, we can't keep pushing this one solution of environment is good, because we know what that has meant for the last 120 years. The environment is good for a certain swath of people who have privilege, is what it has essentially meant. And some city and nonprofit staff acknowledged awareness of green gentrification fears, of climate gentrification fears in socially vulnerable communities. And one city staff member said that they were grappling with it, but expressed skepticism about how much they could achieve through their community partnering work. And he says, we're trying to come to terms with the fact that no matter what the intention is, no matter what longtime resident community leader plants the tree, the property value goes up and it becomes a more desirable place to live. And the people with more money, they're the ones that get their desires fulfilled. So there was an understanding and concern among some city and nonprofit environmental employees that this dilemma exists, and even starting to, experiment with ways out of this dilemma. And local activists and community-based organization staff in urban and overburdened neighborhoods have also been trying to procure GRI to address extreme heat challenges, flooding, and a lack of community gathering spaces. And they've been doing this while also working to counteract longtime public disinvestment, but also pressure from new fast-moving private reinvestment. And a local organizer in charge of greening and climate resilience partnerships in North Philly said that she also worries about future green climate gentrification. She said that many residents have already been displaced from the city center in successive waves of gentrification, despite community organizing and social services to prevent displacement. But they're working swiftly on establishing community land trusts and other community-owned infrastructure. She says people may think that we're too late. We're not. There are a lot of organizations that are now too late, and you can't purchase property affordably, and neighbors are selling their homes, so they're already being pushed out. So this, they're moving quickly with these community land trusts and other community-owned or infrastructure as a tool for prevention. And speaking of similar challenges in a West Philly neighborhood, a community-based organizer said simply, neighborhoods that get wiped out by gentrification are the least organized and the least prepared. They didn't see it coming. And he talked about how residents were basically being assaulted by these "We Buy Homes" signs and solicitations, saying that you can't afford to repair your home. You can't, so why don't you sell it to us for cheap? And so once, they also had a community center at one point that was converted into a private museum. Their community gardens were constantly at risk of being sold off through this through sort of an opaque city council process for vacant lands. And so they were working hard as well in different ways to try to mitigate some of these issues. Well, to sort of wrap up here, I think our study demonstrates how socially vulnerable residents face a perpetual double insecurity and displacement risk, one by climate risks and impacts, and the other by climate gentrification. And even as cities start to take an equity lens toward climate resilience, even as funding becomes more geared toward assisting overburdened neighborhoods with climate protection, if the factors driving vulnerability to gentrification remain unmitigated, those residents will simply not benefit in the long run. And this, our customized or vulnerability assessment really provides a tool for predicting the extent to which socially vulnerable residents might be at risk of climate gentrification, and it highlights how and where to mitigate harmful development to prevent displacement, but also to bolster adaptive capacity through strengthening social infrastructure. And just, I want to leave you with this for food, as like food for thought, or I hope that this presentation has provided food for thought. I would love to hear your feedback and thinking about New Jersey, its coastal cities and towns. I have these photos from, I think, Hurricane Ida, the recent heavy rainfall just last month, showing significant impacts in places like Newark and Atlantic City and Asbury Park. And all of these cities have very large overburdened communities, and they're particularly impermeable in terms of having large parts of those cities being covered in concrete and asphalt. They are also undergoing important urban redevelopment projects, including climate adaptation projects. And I have some funding that's come through very recently from an NSF grant to begin mapping vulnerabilities to climate gentrification in New Jersey and developing stakeholder workshops to be able to exchange knowledge with various practitioners, civic actors, and hopefully co-produce a model for programs of prediction and prevention in New Jersey coastal cities and towns. Municipalities oftentimes sort of admit to feeling an incapacity to address this paradox. So we need to act before this climate gentrification takes place. So I hope to hear from you and receive your feedback. Thank you very much for your attention.
Well, thank you so much, Dr. Trucker. We have a few questions that we're going to address right now. I know a couple of questions were already answered by Dr. Chen, but we're going to re-ask you so we have them as part of the recording. So first of all, do you think wind farm monopiles could help break the offshore wave energy?
This I honestly don't know. I can give a reasonable guess. I feel the impact there, but it's small. How about that? Yeah, I think because the wind farm is in terms of the like a spatial scale is very small compared to the entire space. So I feel that's for the wind farm, I feel the most impact is for the circulation. Maybe that impacts some like an ecosystem over there, I feel, but not for the beach, not for the beach erosion. The way that this part, I don't think so. How do you think, Shuting?
Something else for you to study, but once they're in there, we can see how.
I don't know that. I don't know that answer.
Yeah, I kind of agree. It's probably depending on the scale, probably hard to tell, especially if it's offshore versus the beach part.
Okay. Another question for you, Dr. Chen. Can you use drone technology to map the ocean and bay floors?
We do have a colleague in our department is a drone expert. I know that drone can mostly capture the stuff above the water. That's very well. Actually, we can use some photo geometry, get a photograph from different angle, actually can reconstruct the 3D, but that's limited to the stuff above the ground, above the water level. So for the stuff that underneath the water, we call bathymetry. We have to rely on some traditional method like a echo sounder. That this is more maybe LiDAR, which is the high energy light can penetrate, but it can only limit to very shallow water during the calm condition. You look at our ocean, every time you look at it, it's like a lot of like a suspended sediment, a lot of foams, right? So it's for the light, it's very difficult to penetrate. So the drone with any sensor, it's difficult to measure anything underneath the water, no matter how. Yeah, even for the shallow water, we cannot look into it. So mostly we rely on a traditional method. Yeah, that's my answer.
We'll have to get you a better boat for that, though.
Yeah.
Going out in a canoe.
For sure. Yeah.
Another question was, if you're using any of the MyCoast data for your studies.
No, this is something new to me. I can look into this. Thanks for the people who answer this. I look into this. Thank you.
Okay. Question for Dr. Liu. Are you working and studying algal studying algal and the use of converting to biofuel? Are you doing any additional studies with algae, I guess, using it to convert to biofuel? Because someone was using a program called STEAM Tank Challenge, and have several high school students team in Central Jersey that are studying local algal blooms and uses. So
yeah, it's very interesting topic. Personally, I haven't done anything related to the biofuel for now, but I'm actually talking with some of the professor at King in our chemistry department on some collaborating idea of like growing the algae and looking at how at different conditions, how the algae are actually changing in terms of their light harvesting systems, and which can be related to the biofuel idea that's mentioned here. Because some algae, they produce some volatile organic compounds that some of them are the key components for the biofuels. So which can be related to something conditions we need to check first, and then to see how what is the driving factor to produce more of that on the different conditions. So it's a very interesting topic, and I really interested in the STEAM program that's mentioned here. So if you need want to talk more about that, we can connect offline. So thank you.
great. Now a question for Dr. Chakri. How is actually gentrification being measured? By property values? How are you actually measuring that in your studies?
Oh yeah, that's a great question. So we operationalized gentrification in Philadelphia's census tracts basically as combined tract increases in median gross rent, in residents earning above the citywide median income. Then we also looked at the racial background of the residents. So we looked at white residents and residents with college degrees or higher. And then we also looked at a parallel. So those things would be the increasing aspects of gentrification. We looked at multiple factors that were increasing, and then factors that were in parallel decreasing, such as a decrease in Black and Hispanic residents in a particular census tract. And so that basically meant that we captured much more change than most local gentrification studies do, where, you know, they tend to typically focus on simply property values, or they might only focus on like college educated residents or income. So, yeah.
And one last question for you is that after gentrification has occurred, is more being done to prevent flooding or solve other environmental issues such as pollution than was done before gentrification?
Yeah, that's a great question. So in our study, we found that greening followed gentrification, or sorry, greening. So the neighborhoods that were greened were also the neighborhoods that were gentrifying in Philadelphia. We also found, because we looked at several different periods, that greening continued to increase even after gentrification had occurred. So it seemed to point out that actually, you know, as a neighborhood becomes more sort of privileged in a social perspective, it also continued to become increasingly more environmentally privileged, which meant that, you know, more sort of this climate resilient infrastructure continued to get concentrated in the same areas, right? And then sort of continuing to neglect the areas that actually needed to have this infrastructure even more so, or as much.
Yeah, I mean, it's something that I think we don't really consider, because I mean, we here at ANJAC, I mean, we have a lot of grants that we're putting in green infrastructure projects in a lot of overburdened communities, and we don't really think about the fact that, like, we're looking at it from perspective, like, we're trying to help prevent flooding in your area, or, you know, get the water infiltrated into the ground without thinking about the social, you know, other effects that might happen by creating more of a green space, what it might affect, but the negative effects perhaps could be on people that are already living there, that their property values might go up and that they'll be forced out living there. That's something that we don't really take in consideration when we're looking at these green infrastructure projects, and something that we really need to address. And it's something I know that I don't really think about when we're doing these projects. And I know you probably want to maybe chime in on that, Jen. I don't know.
Yeah, it seems like a compounding issue. I mean, if there's an overburdened community that is suffering with the impacts of flooding, and we or someone else are able to come in with grant money and resolve or partially resolve that flooding, and then that makes their property values go up, and then they can't afford the taxes on that property, then that becomes a real issue. And that's hi, New Jersey legislature, we need help in solving this issue, because this is bigger than any one community group or environmental organization or community health organization. This is a tax restructuring issue to help people keep people in their homes. So I don't have the solution to that tonight, but thanks for giving me more to put on our 2024 plan to deal with.
Okay. No problem.
And we're going to come back to you, because we're going to need more from your brain and other brains to solve that particular problem. But yeah, thanks for highlighting it.
Happy to stay in conversation. And you're definitely not alone in not thinking about that issue in terms of the long-term planning, the long-term benefits, like who's going to continue to benefit. So, you know, and it's a difficult dilemma. It's a dilemma that anytime we try to improve overburdened neighborhoods, you sort of tend to face this same issue. So probably having more people in the room from different backgrounds is probably why I'm happy to be at the social sciences and the environmental science department, because I get the chance to kind of put my head together with people like, you know, Dr. Liu, Dr. Chang, like to really think about these issues together. We have to do that.
Yeah, because the flooding issues need to be addressed. I mean, the solutions don't do anything, because
Exactly.
that's a compounding issue with mold and health and, you know, all kinds of issues. So the problem needs to be fixed, but then the ramifications of fixing the problem need to be managed. So yeah, and thanks for highlighting Philly. Philly's my hometown, which is also, you know, go Phillies, which I understand they're up. So
Oh, good. Awesome.
yeah, so thank you for highlighting that. I appreciate it.
having
Always fun to look back across the river. Been in Jersey a long time, but to see something from Philly, so thank you.
Sure, thank you for having me.
I appreciate everyone being here tonight, and thank you so much. It was quite a informative session. I think everyone learned a lot, and I know I did. Thank you so much.
Thank you. Take care. Go Phillies.
Go
Take care.
Phillies, yes.
Go
Bye.
Phillies.